So Chapter 7, One Sample Inference. So now that you have all of this information about descriptive statistics that we did in Unit 1 and probabilities that we did in Unit 2, it's now time to weave these kind of seemingly separate topics together to start inferential statistics. So there are two branches of inferential statistics. One of those is hypothesis testing. And the other is confidence intervals. So hypothesis testing is making a decision about a parameter based on a statistic. Okay, so again, making decisions about the population based on things we compute from sample data, so our definition of doing inferential statistics. And a confidence interval is estimating the actual value of the parameter based on statistics. So again, we're making a guess about a population parameter based on something we've computed from sample data. So again, meeting our definition for inferential statistics. So 7.1 is just going to focus on the basics of hypothesis testing. And there are a lot of new terms that we get in section 7.1, but they're actually words to identify kind of pieces of this hypothesis test that we've already seen in the last couple chapters. We just didn't have these names attached to them yet. So to understand the process of a hypothesis test, you need to first have an understanding of what a hypothesis is, which is just an educated guess about a parameter. Okay, so again, this doing inferential statistics is just basically making guesses, although educated, but still just guesses nonetheless. So now, if someone claims that the value of the parameter is some specified value, and you have no reason to doubt that, then you're done. However, if you feel you have evidence that shows that the hypothesized value is incorrect, then you would perform a hypothesis test. Okay. So it kind of goes like this, where we have some claim is made about the population, and then again, if we believe that claim, we're just done. But if we feel like, as we've collected data and so on, that this hypothesis is incorrect, okay, so sample data are collected from that population. So this is where our probabilities come into play from the last couple chapters, because we need to then answer a very important question. Because we know that the sample result we get, like a sample mean, is very rarely going to match exactly what the population mean is. There's going to be these random sample fluctuations. But how far do we let it fluctuate before we feel that the parameter value is incorrect? And so that's why we spent this last unit learning about probabilities. So did we get an unusual or a not so unusual sample result, assuming the claim about the population is true? Okay, if it's not so unusual, then we don't reject the claim about the population. But when we saw these unusual results in the last chapter, okay, we started thinking about what that would mean about the parameter. So if unusual results happen, then we reject the claim about the population parameter. So we had some homework sets that were like that, where we saw an unusually high sample mean, and so then we concluded that the population mean was higher than claimed. Or if we saw an unusually low sample proportion, we led that then to conclude that the actual population proportion was probably lower than what they had claimed. So this idea of unusual results that we spent some time with in these last units on probability are going to be what help us make our guesses be educated guesses. So once you collect the data and then determine if that sample result is unusual or not using the methods from the previous chapters. So the last few sections of Chapter 6 were preparing you for these probability computations. So remember, all data is either qualitative or quantitative. So if you have qualitative data, there will be some claimed value of P for the population. And you'll gather some data and you'll compute some value of P hat from the collected sample data. And then after checking some conditions, we can use the normal distribution as an approximation to the sampling distribution of the proportion. Okay, so in here we're talking about the sampling distribution, so the distribution of all values possible for P hat for a given sample size to compute the probability. But if you have quantitative data, Then there will be some claim about the value of mu, the population mean, and we will compute the value of x bar from the collected sample data, and then again, if certain conditions check out, we can use the normal distribution as an approximation to the sampling distribution of the mean. And again, we're talking about a sampling distribution, so it's the distribution of all possible values of x bar for a given sample size to compute that probability. Now we're also going to get another distribution for quantitative in this data in this chapter called the t-distribution, and we'll see why we need that distribution when we get there. It's another bell-shaped curve like the normal distribution, but again, we'll look at that in a later section.